अस्सलाम वालेकुम एवरीवन। क्या हाल है? वालेकुम सलाम. Sir, when are you going to start posting AS content? From the coming week, inshallah. Let me know what videos of AS you guys want me to make. Okay, I was thinking to start with volume. People have requested volume. Okay, I'd appreciate if all the people who are watching would just like the stream. What is integration? Well, I hope you're not an ad math student. सर ओ लेवल मैथ्स के ईयरली पास पेपर्स कब सॉल्व करेंगे? सो ओ लेवल मैथ के ईयरली पास पेपर्स अभी तो टाइम है, टुवर्ड्स द एंड करेंगे. ठीक है, वेक्टर्स पार्ट 3 इंशाल्लाह कल आ जाएगा. ठीक है, आई हैव मेड द वीडियो, जस्ट नीड टू एडिट इट and we'll post it by tomorrow. Okay, tomorrow evening inshallah for sure. Okay, chana. So let's start, shall we? Now as you can see by the name of today's stream, हम लोग करेंगे मुश्किल past paper questions. Okay, we're not going to do the easy ones, we're going to do the difficult ones. All right, now you might be thinking that if I don't know the concept, will I be able to understand? So the answer is yes, you will be able to understand even if you don't know the basic concepts of well, you should know the basic concepts of integration, obviously. Okay, like how do you integrate any power function, how do you integrate a composite function. But if you haven't formally done integration, so that's fine, we'll do a few questions and then you'll get the hang of it. Okay, itna koi rocket science nahi hai, but still I have chosen difficult questions particularly that we're going to solve. Okay, all right, now so this is a PDF which I've attached the link to in the description. Okay, you can download it from there. All right. Sir, are they bringing AdMath in maths too recently? Yes, they are. Okay. Okay, now let's solve a few questions, then I'll take your questions. Okay, so this is a question that I'm going to solve. This is from May-June 2012. This is back in the time when there was a choice in the exam. Okay, as you can see that there's an either or. So you had two questions that you had to solve. Okay, it used to be an either or scenario. So this is the question that we're going to solve. Okay, it's a difficult question. Altogether, it's a 10-mark question. All right, so let's see how we can do this. Okay, so let me insert a page over here. Okay, let's see what it says. So it says here the diagram shows part of the curve y equals to 9x square minus x cube, which meets the x-axis at the origin O, and at point A, the line y minus 2x equals plus 18 equals to 0 passes through A and meets the y-axis at point B. Okay, now I'm going to solve this question, so let's get to it. So the first part says show that for x is greater than or equal to 0, 9x square minus x cube is lesser than or equal to 108. Okay, now it's really important that you understand what this question is trying to ask here. Okay, it's a show that question. That means there's no answer given to this question. You just have to show that it is indeed less than or equal to 108. Now, this is basically the equation of the curve, and you need to show that the equation of the curve is always lesser than or equal to 108. What that means is that you need to show that the maximum point of y equals to 9x square minus x cube is 108. Now, how do you find out the maximum or the minimum point? There's one way to do it. Okay, there's no other way to do it, and that is you differentiate it and you set it equal to 0. Okay, so ये जो आपसे सवाल कह रहे हैं ना कि show that it's lesser than or equal to 108, ये basically इस point की बात कर रहा है. Okay, this is the point that you have to show that it's 108. That will tell us that all the other points are lesser than or equal to 108. Okay, so here's what we're going to do. We're going to differentiate it, set it equal to 0. So if you find out dy by dx, so that's going to be 18x minus 3x square, set it equal to 0. Okay, so 18x equals to 3x square, which means that 18 equals to 3x, which means x equals to 6. Now remember, you've only found out the value of x. Now in order to find out the value of y, you're going to plug this back in. So if you plug this back in, let's see what happens. 9 into 6 square minus 6 cube. Now if you evaluate this, 6 square is 36. 36 into 9, let's see what that is. 36 into 9 is 324 minus the cube of 6, so we get 108. Okay, so that means the maximum point of y equals to 9x square minus x cube is 108. Okay, therefore 9x square minus x cube is lesser than or equal to 108 for x is greater than or equal to 0. Okay, that means ab x ki koi bhi value, doesn't matter what the value of x is, as long as it's greater than or equal to 0, the maximum value that this curve can ever reach is 108. Okay, so I hope that helps. I hope it's clear now. I hope the first part is clear. Now let's do part 2. Okay, and then I'll take your questions. So part 2 says find the area of the shaded region bounded by the curve, the line AB and the y-axis. So we have to find the area of the shaded region, and you can see that the shaded region is bounded by two things mainly. The curve in the x-axis, okay, and this line in the x-axis, and of course there's the y-axis as well. Okay, so let's start with finding the area under the curve. Okay, so theoretically hum kya karenge? Theoretically we will find the area under the curve. Okay, and then in this we're going to add the area of this region. Okay, and this region, if you think about it, is a triangle. So area of triangle OBA. ठीक है, ये दो एरियाज निकालेंगे और इन दोनों को हमने ऐड करना है. ओके, ये वाली चीज़ करनी बहुत ज़रूरी है. यू नीड टू मेक अ रोड मैप as to what you're going to do in order to get to the final answer. Okay, so before I can find out the area under the curve, that means I need to integrate it. Okay, I need to integrate 9x square minus x cube, but I need to know what the limits are. Now I can clearly see that the lower limit is 0. Now I need to know what the upper limit is. So upper limit क्या है, कैसे निकालेंगे? This is the point you can see. So there are two things that are happening at this point. Okay, the line and the curve are intersecting, number one. Okay, also the curve is cutting the x-axis. So if you read the question, it says which meets the x-axis at the origin O and the point A. The line y minus 2x plus 18 passes through A. So A से दोनों points गुजर रहे हैं, and A is a point since it's on the x-axis. So A will have coordinates such as x comma 0. So there will be some x value, and of course the y value will be equal to 0. Okay, so we need to find out the x value, for which what we're going to do is we're going to take this equation of the curve and we're going to set it equal to 0. Now can I factor out something? Yes, I can. I can very easily factor out x square. So we have 9 minus x, which is equal to 0. That means x square equals to 0, or 9 minus x equals to 0, which means x equals to 9. Now 0 to hone se raha hai, theek hai. 0 in fact is this point, so we can clearly see that this can't be 0. So that means the value of a, the x coordinate of a in fact is 9. So the coordinates are 9 comma 0. Okay, so now we know what the limits are. So 9x square minus x cube within the limits 9 and 0. So this is something that you should, once you've figured out the answer, you should check this using your calculator whether you've done it correctly or not. Okay, very important. So first of all, let's integrate this. So it's going to be 9x cube upon 3. Remember, we're adding 1 to the power, dividing by the new power. And now we're going to raise it. Now we're going to plug in the upper limit minus the lower limit. So let's plug in the upper limit. So 9 into 9 cube upon 3 minus 9 to the power 4 upon 4. And if you plug in the lower limit, you really don't have to. Why? Because the answer is going to be 0. Okay, so let's see what we get. 9 into 9 to the power of 3. 9 into 9 to the power of 3 upon 3 minus 9 to the power of 4 upon 4. So here's what we're getting. 2187 upon 4. Okay, now I would prefer to check this. Okay, so मैं कैलकुलेटर में जो इंटीग्रेशन वाली फीचर है वो यूज़ करके मैं इसको चेक करूँ, so I can be 100% sure. I've made videos on this as to how you guys can do this, so make sure to check it out. It's very important, can save you a lot of marks. So I'm going to check my answer. Yep, it's correct. Okay, so far so good, everything's on track. Okay, now the next thing you need to find out is you need to find out the area of triangle. So we found out the area of the curve. Okay, now let's find out the area of triangle. Area of triangle, कौन सा triangle? OBA. Okay, so as we know, area of triangle is half into base into height. Okay, now as far as the base is concerned, we can consider this length to be our base very conveniently. Okay, इसको हम base मान सकते हैं. ये 9 आ गया. ठीक है, in that case इसको height लेना पड़ेगा. अब height कैसे निकालेंगे? We need to find out the point at which the line cuts the y-axis. So if I want to find out the point at which this line cuts the y-axis, what do I need to do? I need to plug in x as 0. So y minus 2 into 0 plus 18 equals to 0. Okay, that means y plus 18 equals to 0, which means y equals to minus 18. Okay, now this is not drawn to scale. You can see that ये 108 है, तो ये minus 18 kind of makes sense. Okay, you might think it's very close to the origin, so minus 18 हो सकता है आपको थोड़ा अजीब सा लगे, but it's not drawn to scale. Okay, it says here, in fact, it's not drawn to scale. Okay, so we have the base, we have the height. The base is 9. The height is, obviously we're not going to take minus 18, so we'll just take 18. So 2 1s are, 2 9s are. So 9 into 9 is 81. Now it's time to find out the total area. Okay, so the total area will be equal to 2187 upon 4 plus 81. Okay, so let's work this out. So we have 627.75. Let's see what the answer is. This is question number 4. Okay, 627.75, and then if you give it correct to 3 significant figures, so that would be 627.75, that would be 628. 628 centimeter square. Actually, not centimeter square, just unit square. Okay, 3 significant figures. Make sure to read the question and see अगर उसने कोई specific form में नहीं मांगा. Sometimes the question says inexact form or whatever. So make sure to read the question carefully before you give your final answer. Alright, now let's see what questions you guys have. Okay, कोई काम की चीज़ है that I missed? Or are you guys just fighting amongst yourself? नेक्स्ट सर में कल अकाउंट्स का एग्ज़ाम है सर इन पार्ट ए इट कांट बी ग्रेटर देन 108 नो इट कांट बी ग्रेटर देन 108 क्योंकि दैट्स द वाई कोऑर्डिनेट ऑफ द टर्निंग पॉइंट सो दैट्स इट ऑलराइट सर इज रिजॉल्विंग वेलोसिटी एक्सक्लूडेड नहीं भाई रिजॉल्विंग वेलोसिटी इज़ नॉट एक्सक्लूडेड I've mentioned it quite a few times. In fact, if you haven't prepared it, kal inshallah video aa jayegi where you can learn it from scratch. Okay? Alright. So anything else? Sir, aaj tayari start karun to A star aa jayega. Okay. I really can't say that. Inshallah. Okay, I'm not going to answer that question. There is mutual respect. Now, I don't know what exactly you mean by admire. Sir, can you please explain how we got the value of x for A's coordinate? Okay, so A is the point where the curve is cutting the x-axis. Okay, so all I did was equated y to 0. And by the way, now that you've asked me that question, here's what we could have also done. Since A is the point that's common on the line and the curve both, so we could have just, in the equation of the line, equated y as 0. Okay, we could have done that as well. Why do you care about my views on him? What difference will it make? Khair, anyway, let's do this question. So, isme we have a bit of trigonometry. Okay, so I hope you guys know how to integrate trigonometric functions. Okay, और ये भी by the way 2012 का इस question है. Okay, let's see what it says. So it says here, the diagram shows part of the curve y equals to 2 sine 3x. The normal to the curve y equals to 2 sine 3x at the point where x equals to pi upon 9 meets the y-axis at the point P. Okay, so here we're talking about something new, and that is the normal to the curve. Okay, so that means we need to first find out the equation of the normal before we can find out the coordinates of P, which we have to do. And with some 5-mark questions, that means there's a decent amount of working that's required. Okay, now how do you find out the equation of normal? Well, the first thing you need is you need the gradient of normal. How do you find out the gradient of normal? I've made videos on this as well, how to find the equation of tangent and normal. Okay, so you can learn just the basic theory from there. So you differentiate, the differential of sine is cos, so it's going to be 2 cos 3x, and then don't forget to multiply it by the differential of the angle, which is 3x, differential of which is going to be 3. Okay, So this becomes what? This becomes 6 cos 3x. Okay. Now, if you plug in x as pi upon 9, you will then have the gradient of tangent. Okay. Because if you plug in anything in dy by dx, you end up finding out the gradient of tangent. Okay. So 6 cos, make a fraction, 3 pi by 9. So what do we have? We have 3. So the gradient of tangent equals to 3. And, if you keep your eyes and ears open, well, I'm afraid that some students might end up taking the gradient of normal as 3. Okay. But if you keep your eyes and ears open, you can see that this is a downward sloping line. So that means the gradient of this line has to be negative. Okay. 3 जो आप देख रहे हो वो basically tangent का gradient है. So that means the gradient of this line would be minus 1 upon 3. Okay. So now that we have the gradient, okay, we have the gradient of normal, which is minus 1 upon 3. We have the x coordinate, which is pi upon 9. Now, in order to find out the complete equation, we need to find out the y coordinate as well. So how do we find out the y coordinate? We plug in this pi upon 9 in the original equation. So 2 sine 3 pi upon 9. Okay. So let's work this out. 2 sine 3 pi upon 9. All right, let's see what do we have. So we have square root of 3. So the y coordinate is under root 3. Okay. Now let's form an equation, and then we will find out the coordinates of point P. So y minus under root 3, okay, equals to m, which is minus 1 upon 3, x minus pi by 9. Ab kyunki we don't really have to give the equation, all right, so you can immediately just plug in 0 in place of x. Okay. But if you read the question further, actually, it says find the area of the shaded region bounded by the curve and the normal, the normal, and the y-axis. So I think it's best that we form an equation. Okay, so it's going to be 3y minus 3 under root 3 equals to minus x plus pi upon 9. So this right here, let's write it nicely, minus x plus pi upon 9 plus 3 under root 3 is the equation of normal. Okay. Now that you have the equation of normal, we know very well that the coordinates of P are going to be 0 comma y. Okay. So if you plug in 0 in place of x, so 3y equals to pi upon 9 plus 3 under root 3. Okay. So y is equals to whatever this turns out to be, that is pi upon 9. Make sure your calculator is in radian mode. 3 under root 3. So we'll divide this by 3. So here we have y is equals to 1.848, which we will round off to 1.85. So now the coordinates of P are 0 comma 1.85. And there you go. That's the answer to the first part. Before I do part 2, let's see if you guys have any questions. Okay. Sir, why pi upon 9? It's given in the question. Any tip on remembering trig identities? You don't have to remember all of them. Just look at the ones that aren't given in the exam and just memorize those. Okay. I like the subscriber count. Thank you. I should do an FAQ. Okay. It's a good idea. Sir, I remember all of this, easy to do, but as soon as I hit the examination hall, my mind goes blank. Okay. Keep practicing. Keep practicing. Okay. Now, so we have the coordinates of P. Now let's find out the area of the shaded region. Okay. Now let me tell you what's the wrong way to do it. The wrong way to do it is to actually think of this as a triangle and then end up finding out the area of triangle. Okay. Now I know this might come as a surprise to those of you who are watching, who are thinking this. And the reason why we can't take this as a triangle is because it's not. Okay. Why is it not a triangle? Yes, this is a straight line, what I'm drawing in green. Okay. Yes, this is also a straight line, what I'm again drawing in green, but this is not a straight line. Okay. The reason why it's not a straight line is because it's part of the curve. All right. So here's what we're going to do. Now this is us trying to sort of come up with a way to find out the area of the shaded region. Okay. जो mind mapping हम कर रहे हैं ना वो बहुत important है. So first we'll find out the area of the shaded region. So first we'll find out the area of trapezium. Okay. So this is what we're going to do. This is the area of trapezium. So that's what we will do. We will find out the area of trapezium. Okay, and once we have found out the area of trapezium, from it, what we're then going to do is we're going to subtract area under the curve. Okay, area under the curve. All right, once you figured this out, that means everything else is just white noise, okay? Now you don't need to worry about anything else. You just need to focus on what you want, okay? So I'm just gonna crop everything and keep this shape over here. Okay, बस ये है हमारे काम का. Okay, now काम करते हैं. Let's add a fresh page over here. Okay, better. Now if I want to find out the area of trapezium, so we have pretty much everything we need in order to find out the area of trapezium. The formula for calculating the area of trapezium is half into sum of parallel sides into height. Okay, so we're calculating the area of trapezium. Now what are the sum of parallel sides? One side, as we can see, is pi upon 9. Okay, now what is the other side going to be? The other side is p, which we just calculated is 1.85. Okay, so these are your parallel lengths. In fact, sorry, it's not pi upon 9, it's actually pi upon 3. Okay, let me just double check. It's pi upon, it's actually under root 3. Okay, my bad. It's actually under root 3. Why is it under root 3? Because when we plugged in pi upon 9 in the equation, what we ended up with was under root 3. Okay, यहाँ पे जब हमने plug in किया था, so we ended up with under root 3. So under root 3 and 1.85 are your parallel sides, and the height is pi upon 9. Okay, so let's find this out. 1 upon 2 into bracket open under root 3 plus 1.85 bracket close into pi upon 9. Just use your calculator, no need to round off values unnecessarily. So here's what we end up with. We've ended up with 0.62518. Since it's not the final answer, that's why I've taken this not correct to 3 significant figures. Okay, now we need to calculate the area under the curve. So for the area under the curve, here's what we need to do. We need to integrate the equation of the curve, which I believe is 2 sine 3x. So 2 sine 3x within the limits pi by 9 and 0. Okay, now be very careful. The integral of sine, so the differential of sine is cos, the differential of cos is minus sine. So the integral of sine is actually minus cos. So it's going to be minus 2 cos 3x, and in differentiation we multiply by the differential of the angle. In integration you divide it by the differential of the angle. So the angle is 3x, differential of which is going to be 3 within the limits pi by 9 and 0. Okay, so let's plug this in the calculator. Minus 2 cos 3 fraction shift pi over 9, okay, over 3. So here's what we get. We get minus 1 upon 3. Now I'm going to plug in 0 where I've plugged in pi upon 9. So if I plug in 0, we get minus 2 upon 3. Okay, so here's what happens. Minus 1 upon 3 plus 2 upon 3 gives us 1 upon 3. Now the final answer, for the final answer, what we'll do is 0.62518. Okay, the area of the trapezium minus the area under the curve, which is 1 upon 3. So let's do that. 0.62518 minus 1 upon 3. So here's the final answer, which is equal to 0.2918. So we'll lock it at 0.292 square units. And there you go. That's the final answer. Now let's see if you have any questions. Okay. So can you upload some more? Yes, AS content is in the pipeline. Don't worry. I'll probably start with S1. Okay, S1 के भी काफ़ी सारे लोगों ने request किया, so I'll start with that. So I had my math exam. Alright, good to hear that. Permutation combinations pe I've recently uploaded a few videos. Okay, if time allows, maybe I'll do a live stream as well. So can we do line integration on this? Yes, you can totally do that. Okay, you can integrate the equation of the line within the limits 0 and pi by 9. You'll get the same answer. Sir, can you please upload some content? Yeah, so I have answered that. I will upload more content on AS as well, inshallah. Okay, so I guess all is well so far. Okay, now let's pick some other difficult question. All right, let's do this one. Let's see what this is. So this is from October, November 2013, paper 1, variant 3. Okay, So it says here the diagram shows part of the curve y equals to 4 minus x square. Show that the area of the shaded region can be written in the form under root 2 upon p, where p is an integer to be found. Okay. Now this is a 6-mark question, so that means you can't just you can't just start solving this question without any strategy. Okay, so you need to come up with a strategy first. So this is the shaded region. It's not a definite shape that we can use a fixed formula and find out the area of the shaded region. Okay, so we need to figure something out. So you can see that this region is basically in between the line and a curve. So that means we need to first find out the area under the curve. Okay, area under the curve. Okay, and from it we need to subtract area of this region. Okay, now what is this region? This is area of trapezium minus the area of trapezium. एक दफ़ा आप ये कर लेंगे ना, तो you will be more confident about your own working. Okay, because now you have a direction in which you're headed. Okay, ये जो आप लोग कहते हैं ना कि एग्जाम में ब्लैंक हो जाते हैं, एग्जाम में ब्लैंक इसलिए हो जाते हैं because when you're practicing, you don't really do it the way that you're supposed to. Okay, irrespective of whether you're doing a question in the exam or you're practicing at home, you need to first, especially with questions like these, you know, that are like 6, 7, 8 marks, where the answer is found by through multiple steps. In that questions, you need to first make a strategy, and a strategy doesn't mean that you really spend a lot of time and, you know, figure out or pen down the strategy to the finest details. No, you don't need to do that. Okay, just like in a broader scheme of things, that what exactly do we need to do in order to find out whatever it is that the question wants us to find out. Okay, so let's find out the area under the curve, for which we need to integrate the curve, which is 4 minus x square, within the limits under root 2 and 0. Now notice this question says do not use a calculator in this question. That means, well, even if you do use a calculator, there's no way the examiner is going to find out. So even if you do use it, just use it smartly. Okay, in the sense that examiner को ये ना clear पता चल जाए कि आपने खुद ज़हमत ही नहीं की, बस सिर्फ calculator में सारी working कर दी. So 4x minus, just a second, yeah, so 4x minus x cube upon 3 within the limits under root 2 and 0. Now notice that you're supposed to give your answer in exact form. Okay, so you have to be careful with the way you plug in your values. So 4 under root 2 minus under root 2 cubed, okay, and this is divided by 3. Now this is with the upper limit plugged in. Now we're going to plug in the lower limit. Okay, now if you plug in the lower limit, you can see कि answer ने eventually क्या आना है, answer ने eventually 0 ही आना है. So there is no need to actually plug it in, just write 0 and that's good enough. Okay, now under root 2 cubed क्या है? Let's find that out. Under root 2 cubed is actually 2 under root 2. So we have 4 under root 2 minus 2 under root 2 upon 3. Now if you want, you can leave this over here, find out the area of trapezium first and then write it in the exact form, or if you want, you can simplify this. I would suggest that you simplify it through LCM. So this we're going to multiply by 3, this also we're going to multiply by 3. So if you multiply this by 3, what you end up with is 12 under root 2 minus 2 under root 2. So 12 under root 2 minus 2 under root 2 is equals to 10 under root 2 upon 3. So this is area under the curve. Okay, now we'll leave this over here. Let's find out the area of the trapezium. So we'll do that in green. Area of trapezium. And in this case also, you can find out the area under the line, but the thing is we don't have the equation of the straight line. So we can always find the equation of the straight line and then find the area, but I wouldn't recommend that. That'll just be a total waste of time. Okay, when you have already, when you have everything that you need, you have, well, you don't have the parallel lengths. Okay, but still finding this parallel length is still much easier compared to finding out the equation. So in order to find out this y value, all you need to do is plug in under root 2. Okay, if you plug in under root 2 in the equation, so you get y equals to 2. Okay, root 2 squared is 2, 4 minus 2 is 2. Okay, so now that we have everything, we have this parallel length, which is 4, we have this parallel length, which is 2, and then we have the height, which is under root 2. Okay, so it's just the home stretch now. Half into sum of parallel lengths, that means 4 plus under root 2 into, sorry, not under root 2 actually, 4 plus 2, okay, into the height, which is under root 2. So 4 plus 2 is 6, alright, 6 upon 2 is 3, so we have 3 under root 2 as our final answer, okay, of the, as our answer to area of trapezium. So here's what we're doing now, 10 under root 2 upon 3, minus 3 under root 2. So we'll have to take out the LCM, of course. So the LCM is going to be 3. Okay, so 10 under root 2 as it is. This we multiply by 3. So this also we multiply by 3 minus 9 under root 2. So our final answer is simply under root 2 upon 3. Okay, now the question said that your final answer should be in the form of under root 2 upon p, where p is an integer to be found. So what's the value of p? You can see that p equals to 3. And there you go. That's it. That's your final answer. Now let's see if you have any questions. Can we do line minus curve within the limits? Okay, I think I already answered that. The answer is 3. Yep, the answer is 3. Sir, are there any integration questions related to ln equations? So there are questions where if you integrate, it leads to ln. Okay, you don't need to know how to integrate ln, but you need to know what happens, or how is integration, what kind of integration leads to ln. Okay. Sir, do you have videos on ln exponential and logarithmic graphs? I think I did a stream on this. I don't remember exactly, but these are one of those topics that I have planned. Okay, so you'll find a stream on this soon, inshallah. Okay, let's pick another difficult question. All right, let's solve this. This is from October, November 2014. Actually, you know what? This is still relatively easier. Okay, let's do this one. This is a difficult question. This is from May, June 2015, paper 11. Okay, altogether this is a 2 plus 3, 5, 5 plus 5, 10. It's a 10-mark question. Okay, so let's do this. It says the diagram shows part of the line y equals to 3x plus 10. So here it is. And the curve y equals to x cubed minus 5x squared plus 3x plus 10. So here you can see is your curve. The line and the curve both pass through the point A on the y-axis. Alright, the curve has a maximum at the point B and a minimum at the point C. So here's the maximum at point B, here's the minimum at point C. The line through C, okay, parallel to the y-axis, so that's this line, the line CD, intersects the line y equals to 3x plus 10 at the point D. Okay, show that the line AD, which is right over here, is tangent to the curve at A. Okay. Now there's a lot of information, okay? If let's say you've just started doing integration and area under the curve, so there's a lot of information here to process, okay? So for which I would suggest that you read the question one more time, okay? So, and this time we are reading it, and there's an objective behind reading the question, okay? The objective is to try and figure out the values that we can, okay? Like for example, let me show you. So it says here the diagram shows part of the line y equals to 3x plus 10. So this is a line with y equals to 3x plus 10. So that means the y-intercept of this line is going to be 10. So that means immediately we have the coordinates of a, 0, comma 10. Okay. And the curve y equals to so and so. The line and the curve both pass through the point A. So you can see that the constant in the curve and the line, they're both 10, telling us that both of them cut the y-axis at the same value. Okay. So the curve has a maximum at here and a minimum at point C. The line through C, parallel to the y-axis, intersects the line y equals to 3x plus 10 at the point D. Show that the line AD is tangent to the curve at A. Okay, so that means if, let's say, we were to find the gradient of tangent to the curve at point A, okay, the gradient of the tangent should be equal to what? Should be equal to 3. Why? Because that's what the gradient of this line over here is. Okay, so now we've narrowed it down. Okay, now with so much information, we know that we have to do one thing and one thing only, that is to find the gradient of the curve at the point A. Okay, and at the point A basically means x equals to 0, and show that that gradient is equal to 3. Okay, so let's do that. Let's differentiate the equation of the curve. So that's going to be equal to 3x squared minus 10x plus 3. And now let's plug in x equals to 0. If you plug in x equals to 0, the objective is to find the gradient of the tangent at x equals to 0. And you can notice that the gradient of tangent at x equals to 0 is in fact equal to 3. Okay. Now why should it be equal to 3? That's because the gradient of this line is equal to 3. Okay. And that is now equal to the gradient of tangent, which is also 3. Okay. So there you go. Hence proved. Then it says find the x coordinate of B and C. In fact, let me see if there are any questions. Sir Saad, if you okay, that was a funny question. Sir, can you please tell what do we do for compound area between two graphs? So this is an example like that. Okay. So let's see. I have a few more examples lined up, so maybe you'll find your answer later on. Okay. So let me tell you one thing. I can't tell you that this is what you do. Okay. It depends on the question. So if let's say the area is in between two curves, so first you find the area of the curve that's above, and then you find the area of the curve that's below, and then you subtract. Okay. Sir, please do the question with graph under the x-axis. Okay, so later on we will do that. Sir, why can't we only show the coordinates? Okay, what do you mean by that, Nabil? Can you elaborate? Sir Saad. Okay, thank you, Mohsen. Thank you. Like of the tangent and curve. So we don't have the coordinates of tangent. Okay, what you can do is, but that would be really lengthy. No, wait. That there is no other way to do it. This is the only way to do it. Okay. All right. So then it says find the x coordinate of B and C. Okay. So B is what point? B is a point where the curve is maximum. All right. So B is a point where the curve is maximum, and C is a point where the curve is minimum. Okay. So that's what we need to do. We need to find out the maximum and the minimum point. Okay. So how do you find out the maximum and the minimum point? You differentiate and you set it equal to 0. So thankfully we already have dy by dx. It's 3x squared minus 10x plus 3. So that we set this equal to 0. 3x squared minus 10x plus 3 equals to 0. You can do this through middle term breaking or quadratic formula. We say you'd have to be really silly to do this through quadratic formula, because you can very easily do it through middle term breaking. But I'm going to save time and not do either of those, and instead just use my calculator. So one value of x is 3. And the other value of x is 1 upon 3. Okay. Now clearly you can see that you have two values of x. Okay. One is at B. So definitely this value is going to be the smaller of the two. It's going to be 1 upon 3. Okay. And this value at C, x is 3. Okay. Now we had to only find the x coordinate. Okay. So the x coordinate of B is equal to 1 upon 3. And the x coordinate of C is equal to 3. Okay, let me double check the letters. Yeah, so at B x is 1 upon 3 and at C x is 3. Okay, then it says find the area of the shaded region A, B, C, D, showing all your working. Now you notice how this question was so nice to you in a way that it made you do all the hard work. Now it's only asking you to find the area of the shaded region. Okay, so 80% of the effort has already been done. All you have to do now is just use your knowledge of integration, okay, and how you can use it to find the area under the curve, and do just that. Okay, so ek kaam karte hain. Let's take a screenshot of this and bring it with us over here, so we don't have to do a lot of back and forth. Okay, now just give me 1 second. Ye app thoda stall kar rahi hai for some odd reason. Let me open it up again. Yeah, should be fine now. Khair, forget it. Let's just use this. Okay. Now, if I want to find out the area of shaded region, there has to be some working behind it. The working is that we need to, first of all, find out the area of this shape, okay, this larger shape, which is the area of trapezium. Okay, now we might or we may not have enough information to do that. We'll see, okay, as we go along. So this is what we need to do first. We need to first find out the area of trapezium. Area of trapezium. Okay, now how do you find out the area of trapezium? Half into sum of parallel sides into height. Okay, now what will be the two parallel sides? Now the interesting thing is this. We have this, okay, just give me 1 minute. I don't know, this app is acting weird. Okay, so just give me 1 minute. Okay, it's fine now. There you go. Sorry about that. Acha. So as I was saying, so notice that for point D we have the x coordinate, but we really have to find out the y coordinate before we can determine what the two parallel lines are. So how will I find out the y coordinate? I'll just plug in 3 in this equation. Okay. So if I plug in 3 in this equation, 3 times 3 is 9, 9 plus 10 is 19. So that means the y coordinate is 19. Okay. And do we have the height? Yes, we do have the height. Height of the trapezium is going to be what? Height of the trapezium is going to be 3. Okay. Why? Because from A all the way to D, the perpendicular distance, as you can see, is 3. Okay. So half into sum of parallel sides, which happen to be 10 and 19, into the height, which is 3. Okay, let's double check that. Yep, 10, 19, parallel sides, the height is 3. Okay. So 10 plus 19 is 29. So 10 plus 19 into 3 divided by 2. So here's what we have. We have 87 upon 2. So we'll leave this over here for now. Okay. Next is that we need to find out the area under the curve. Okay. Now, if I need to find out the area under the curve, what limits am I going to use? I'm going to use 0 and 3. Okay. So from this, I need to subtract the area under the curve. Okay, so that means I need to integrate the equation of the curve, which is x cubed minus 5x squared plus 3x plus 10, x cubed minus 5x squared plus 3x plus 10. Let's just double check to be on the safe side. Yep, within the limits 3 and 0. Why 3 and 0? Because both of them meet at point A. Okay, here's the line above the curve and here is the curve below the line. Okay, now let's do the integration part. So x power 4 upon 4 minus 5x cubed upon 3 plus 3x squared upon 2 plus 10x. So we add 1 to the power, divide by the new power within the limits 3 and 0. Okay, so now let's plug in the limits. 3 power 4 upon 4 minus 5 into 3 cube upon 3 plus 3 into 3 square upon 2 plus 10 into 3. And then if you plug in 0, it's quite evident that everything will be 0. So it's just going to be minus 0. All right. Now, 3 power 4 upon 4 minus 5 into 3 cube upon 3 plus 3 into 3 square. We can just do that directly. That's going to be 27. And 10 into 3, we can do that directly as well. So that's going to be 30. So the final answer is 75 upon 4. Now, before I go on and find the final answer by subtracting the 2, I will check my answer, okay, just to make sure that I've done correctly. So x cubed minus 5x square plus 3x plus 10 within the limits 0 and 3. Yep, so the answer is 75 upon 4, so that means everything's on track. Now, in order to find out the area of shaded region, all you have to do now is take 87 upon 2, from it subtract 75 upon 4, and there you go. That's going to be your final answer. 87 upon 2 minus 75 upon 4. So the answer is 24.75 unit square, or square units. Doesn't really matter what unit you use. Okay, now take a good look at what I've done. Let me know if you have any questions. In the meantime, I'll just check the answer. Yep, 24.75 it is. Okay. What would you guys rate this question on a scale of 1 to 10? Difficulty level. In the meantime, I'm going to try and find an even more difficult question. Okay, this one looks interesting. Yeah, let's do this one. ये करते हैं या फिर ये वाला करते हैं. In fact, this has E in it as well, so we learn how to integrate E. 4 out of 10. Okay, that's brave. It's a good thing. It's a good thing you guys think it's a 4 on 10. Hey man, I sucked at math. Thank you, Imran. You're welcome. Sir, it's more easy to simply integrate the equation of the line since it's... Okay, so that's up to you. I always... ये अपनी preference की बात है. I always prefer to find out the area of the shape, be it a triangle or a trapezium. Okay, that's what I prefer. It's up to you. Sir, May June 2022 area under the curve is hard. Okay. So let's do this question. Okay, this one also is a pretty difficult one. It's a 10-mark question and it's fairly recent as well. It's May, June 2018, paper 12. Okay. All right, let's see what this says. It says the diagram shows the graph of the curve y equals to so and so. The curve meets the y-axis at point A. So here you can see the curve is meeting the y-axis at point A. The normal to the curve at A, so here's the normal to the curve at A, meets the x-axis at point B. Okay, find the area of the shaded region enclosed by the curve, the line AB, and the line through B parallel to the y-axis. So it's talking about this line basically. Give you an answer in the form of E upon A, where A is a constant. You must show all your working. Okay, so the examiner, why is the examiner telling you to show all your working? That's because the examiner knows that there are occasions where you can simply use the calculator to get to the final answer, but you still have to show your working. Okay, now first things first, let's start by, so theoretically if I want to find out the area of shaded region, here's what we're going to do. Theoretically we're going to find out the area under the curve. Okay, area under the curve. All right, now if you want you can actually write down the limits as well. Okay, but since we don't have the x coordinate of B, actually that's not a good idea. Okay, but so we'll just leave it at that. Area under the curve minus area of triangle. And again, you can find out the equation of the straight line and then integrate that. Area of triangle OAP. Okay. So let's start by finding out the area under the curve. Now, if I want to find out the area under the curve, I need to know what the limits are. Okay. So, I just realized that we could have also done. Okay, no, we can't do that. I was going to say that we could have done area of trapezium, but please don't fall for that. This is not a trapezium. This is not a straight line. Okay, so I need to find out basically the coordinates of point B. Okay, you can tell that the lower limit is going to be 0. Okay, because A has coordinates 0 comma something. Okay, but we need to find out what the upper limit is. Okay, in fact let's start by finding out the coordinates of A. So if I want to find out the coordinates of A is a point where the curve is cutting the y-axis. That means it's going to have equation, it's going to have coordinates something like this. So here's what we're going to do. We're going to plug in 0 in place of E. So E to the power 4 into in place of x, sorry, plus 3 upon 8. So anything raised to the power of 0 is 1. Doesn't matter whether it's a number or E. Okay, so that's going to be 1 plus 3, that's 4, 4 upon 8. So y is equals to 1 upon 2. So that means now the coordinates of A are 0, comma 1 upon 2 or 0, comma 0.5. Doesn't matter how you write it. Okay. Now, why is this? Why was this necessary? You'll find out. Okay, why? Because you have the normal to the curve, which meets the x-axis at the point B, and it meets the y-axis at point A. Okay, so that means before I can find out the coordinates of B, I need to find out the equation of the normal, because at B, it's the equation of normal that's cutting the x-axis. Okay, so that's where we're headed now. We are now taking a detour, and the detour is to find out the equation of the normal. Okay. So we have y, which is equal to e power 4x plus 3 upon 8. Now, how do you integrate e? It's very easy. There's nothing too complicated. But before you do that, I would suggest that you write 8 separately with each term of the numerator. So here's dy by dx. Integrating e is done like this. You have e to the power ax plus b. So if you want to integrate a function like this, you rewrite e to the power ax plus b and simply multiply it by the differential of the power, which is a in this case. So that means e to the power 4x upon 8 as it is, multiplied by the differential of 4x, which is 4, and the differential of 3 upon 8 is going to be 0. So 4 1s are, 4 2s are. So we have 1 upon 2 e to the power 4x, that is our dy by dx. So what's the value of x that we're going to plug in? So since a is on the y-axis, that means x is equals to 0. So we plug in x equals to 0, and when you do that, you now have the equation, the gradient of tangent, which is equal to 1 upon 2. Okay, and you can see that this is a downward sloping line, so there's no way the gradient of this line is going to be 1 upon 2. So the gradient of normal is actually going to be minus 2. And now that you also have the points through which this line is passing, okay, so notice that now you probably understand why this was necessary. So in order to find out the equation of a straight line, you need the gradient and a point through which the line is passing. So we have the gradient, we have this point as well. Now it's just a matter of putting it all together. Y minus 0.5 equals to m, which is minus 2, x minus 0. So y equals to minus 2x plus 0.5. Okay, this is the equation of normal. Now B is a point where you have an x coordinate and the y coordinate is going to be 0. Why? Because it's on the x axis. So we plug in 0 in place of y. So 0 equals to minus 2x plus 0.5, which means 2x equals to 0.5, which means x is equals to 0.5 divided by 2. So that's 0.25. Okay. So far what we have done is we've only gathered the relevant information that we need in order to find out the area under the curve. Okay, so remember I said that this is a slight detour, and don't worry, there was extra space given after this. So don't think that you have to squeeze your answer within the given space. Okay, it's a 10-mark question. Obviously this space for a 10-mark question is not enough. So like I said, so far what we have done is we've only gathered the relevant information to find out the area under the curve. So the coordinates of B are 1 upon 4 comma 0. The coordinates of A, let's write that down, are 0 comma 1 upon 2. Okay, now let's take a screenshot of this and bring it here. Okay. So like I said, we have relevant information to find out the area under the curve. So we're going to do just that. E to the power 4x upon 8 plus 3 upon 8 within the limits 1 upon 4 and 0. Okay. So e to the power 4x upon 8, if you integrate this, so it's going to be 8 into 4. Why 8 into 4? Because in the case of integration, you divide it by the differential of the power. Plus 3 upon 8x within the limits 1 upon 4 and 0. I should have written this over here to save some space. Okay. Now 8 into 4 is 32, so might as well write it as 32 directly. Okay. Now it's time to plug in the values. So 4 into 1 upon 4 upon 32 plus 3 into 32 upon 8. So here is the upper limit plugged in. Now let's plug in the lower limit. So e to the power 0 over 32 plus 3 upon 8 to the power into 0. Okay. So be very careful over here. There's a lot of things can go wrong. Okay. And when you're done, do check your answer with your calculator. So this becomes e over 32 plus 8 ones are, 8 fours are, so plus 12 minus 1 upon 32, because e power 0 is 1, okay, and upon 32. So there you go. And 3 upon 8 into 0 is 0. So this is just the area under the curve. Now I'll leave it over here. I'm not going to simplify it any further. Okay, let's find out the area of triangle, and then it's possible that a few things might cancel out here and there. Okay, so now let's find out. So we have the area under the curve. Should have done this in green. Okay. Okay, anyway, I'll change it now. So all of this is for the area under the curve. Now let's find out, like I said, let's find out the area of the triangle. Okay, so we have enough information to find out the area of triangle, and like I said, you can integrate the equation of a straight line as well, makes no difference. So half into base, which is 1 upon 4, into the height, which is 1 upon 2. Okay, so let's work this out. So this turns out to be 1 upon 2 into 4 is 8, 8 times 2 is 16. Okay, now so we have everything that we need. Now we just have to put it all together, and let's see how the final answer is supposed to be. The final answer is supposed to be in the form of e upon a. Okay, now before I move on, I'm just going to quickly check this answer, okay, and make sure that what I've done is correct. So here we have e to the power of, sorry, wait a minute. So make a fraction, e to the power of 4x, so 4x upon 8, okay, plus 3 upon 8 within the limits 0 and 1 upon 4, which is 0.25. So the answer that turns out to be using a calculator is 0.14744. Okay, now I'm just going to check the decimal value of this, and if the decimal value of this is also the same, that means we've done it correctly. E to the power 1 over 32 plus 12 minus 1 upon 32. Okay, so it is not the same, so that means there's something wrong. Now let's see what we have done wrong over here. So the value of x is correct, 0.25. Within the limits, 4 into 1 upon 4 is e plus 3 upon 8x. So 3 into 4 is 12. 8 1s are, 8 4s are, minus e power 0. Okay. Okay, just a minute. Let me see what I've done wrong. 3x into 1 upon 4 karna hai. 3x into... Oh, yeah, you're right. I don't know where the 32 came from. Thank you for pointing that out. 3 upon 8 into 1 upon 4. Yeah, that's a good question. Where did the 32 came from? Khair. Anyway, whoever pointed that out, thank you so much. So 3 into 1 upon 4 is 3 upon 32. Okay, this should help. So the area, so this is how your calculator can save you from getting a question wrong. Okay, so there are two lessons over here. One is, of course, be careful. Okay, don't make any silly errors like the one that I just made. And the other lesson is use your calculator to make sure that what you've done is correct. So this turns out to be 2 upon 32, okay, which if you simplify, this turns out to be 1 upon 16. So all of this is just the area under the curve, okay. Now let's find out the area of triangle, which I don't know why I've all of a sudden erased it. So area of triangle is equal to half into the base, which is 1 upon 4, into the height, which is 1 upon 2, which is equal to 1 upon 16. Okay, and now everything makes sense, okay. E upon 32 plus 1 upon 16 is the area under the curve minus the area of triangle, which is also 1 upon 16. So our final answer is E upon 32 plus 1 upon 16 minus 1 upon 16. So plus 1 upon 16 and minus 1 upon 16 gets cancelled out. And the final answer is E upon 32, which is how it was supposed to be, where A is a constant and you can see that the value of A is 32. Okay, ये आंसर हमारा आना चाहिए था equal to E upon A as per the question. Okay. All right. Now, this was a good question. What do you guys think? What you memorize, you apply kind of it. Yeah, that's true. So how is it E upon 32? Okay. So I'll tell you why. So I'll give you guys just a quick walkthrough over it. So basically the limit that we were supposed to apply was 1 upon 4 and 32. Okay. So in place of x, it was supposed to be 1 upon 4. Okay. So e to the power of 4 into 1 upon 4 over 32. So 4 into 1 upon 4 is e to the power 1 over 32. And then 3 upon 8 ke saath bhi 1 upon 4 apply karna tha. I don't know why I applied 32. So 3 upon 8 into 1 upon 4 is 3 upon 32. This is going to be 1 upon 32 because e to the power 0, 0 is the lower limit. Okay. And 1 upon 32 is going to be the answer with the lower limit plugged in. You subtract the two. So this is area under the curve. This is area of the triangle. You subtract the two. And now you have the area of the shaded region. Okay, so thoughts on difficulty level of this question on a scale of 1 to 10. E upon 10 difficulty. You know, that actually means it's a lot easier because E ki approximate value is around 2 point something. The approximate value of E is 2.71. So you're saying 2 out of 10. Okay, that's brave. Okay, so I think let's keep it till here only. Okay. Now I will encourage you guys to practice the remaining questions. Okay. Now I'm pretty sure all the other questions that you solve, you will find them pretty easy. Okay. Because we've done all the difficult questions. Now do practice it. Remember, it's very important to practice. Okay. Very important that you, and it should be focused practice. Now when you're practicing, let's say if you're practicing integration, so it's always and let's say you want to practice area under the curve particularly. So just highlight all the questions that deal with area under the curve and practice those only. Okay. So that is what I mean by focused practice. If you want, let's say if you want to practice stationary value. So again, just highlight all the questions that deal with stationary values and practice those only. Okay. Will the PDF be shared? So do you want the PDF with my solutions as well? If yes, so I'll share that as well. Okay. Without the solutions, I've shared it already. You can find it in the description of the group. Okay. So without the PDF, I've shared it. It's in the description. You can check it out. If you want it with my solution, then I'll share that as well. Okay. Is this for 0580? So for AdMaths, it's the same. O level and IGCSE, they're both the same. The paper is the same. Everything's the same. Okay. The only difference is that you have an extra exam in February, March, which is in India only. Okay. Other than that, the paper is the same. Okay. So let's stop here, boys and girls. I will see you inshallah tomorrow, hopefully. Okay. Let's see what I'm streaming tomorrow. And take care. Allah Hafiz. Circle paper, I love you. Good luck to you.